Hello, my name's Tony Shields and I work here at the National Science Learning Centre, and I've got the delightful job of introducing my colleague Jane Winter, who's going to be delivering this session for you. I'd also like to thank Rising Stars, who have organised and booked everybody onto this course and have been the driving force in actually getting this webinar running for you. And the final thank you goes to everybody that's logged on today. You've probably had a really busy day in schools. If it's anything like it is here in York, or misty and cold and horrible, then well done for actually logging in. It's greatly appreciated. I've got my iPad ready and I'm going to be watching Twitter, so hopefully you'll have seen the slides at the beginning which said to use the Twitter handle of Science Voice. So if you are on Twitter, you would like to ask any questions to either Jane or myself here, you can send a message through the Twitter account, put @Science Voice on there, and I'll pick those up and send them over to Jane. We've also got some colleagues here which you won't see today, but we have got 5 other colleagues who are supporting behind the scenes, running everything. So if you do happen to hear some odd noise, it's not mice or ghosts left over from Halloween, it's the staff here that are making all the IT run smoothly. So, at the end of these 3 sessions, we are going to upload these videos up onto YouTube. So if you do have any colleagues that you'd like to share them with, you'll be able to get hold of those and use them at a later date, or maybe even share them in staff meetings. You'll have also noticed we've got 3 code words. We would love for you to join us for all 3 of these webinars, and at the end of that we'll be able to give you a certificate of recognition for the CPD that you've undertaken. So in order to do that, to make sure, instead of having a formal register, we're going to give you a code word, and as you'll see up on the screen we have a word. As I look on my monitor, it looks like the word is written backwards in a mirror image. If that is the case for you and you're struggling to, no, it's absolutely fine, my colleagues have told me it says evolution. So we'll be giving you 2 other code words on each of the evenings, and then you email my colleague Alison Stevens, who's going to issue the certificates for you, or post those out to your school. And my final introduction is to hand over to Alison. I'm going to hand over to Jane Winter, who's recently joined our team here at the National, was very recently teaching in the primary classroom, and is going to be carrying out this session with you and hopefully showing you some resources that you can use in the classroom. So enjoy, send us some messages via Twitter, and yeah, I'll hope to see you next week. Thank you.
Thank you, Tanya. Hello, and again, can I just add my thanks? Thank you so much. I know you'll have had busy, hectic days at school, so well done for getting this far. Working scientifically, that's all I was told, do something on working scientifically, and it's such a big area, isn't it? So just going on, obviously based on this and programme of study, and I think it's very easy to get this, so much writing in, isn't it? It can feel like it's a prescription, what you've got to do. I like to think of it more like a map. It's, you know where you've got to go, but it's up to you how you get there. You've got so many choices to make. You know your children, you're going to adapt what you do to meet their needs. You know what your own interests are, you know what you're good at. So it's all about giving you lots and lots of choices, which doesn't always feel like a good thing, does it? So, moving on, if we could just move to the slides. I think we actually want to get to the second slide. Yeah, right. Sorry about that slight technical hitch. Hopefully that's the last one. Things are going to go so smoothly from now on. So just before we get into some nitty-gritty actual practical science, just a little bit to remind ourselves about what the what working scientifically means. So first of all, we've got 5 types of scientific inquiry. So moving on, that's obviously observation over time, fair and comparative testing, classifying and grouping, pattern seeking, and secondary research. And this is quite new for us because until recently we were all very much into fair testing, and that's as far as it went. So that's a big thing for us to get our heads around. And then another aspect of working scientifically is thinking about all the different scientific skills, and they include planning, observing, recording, evaluating, concluding. They're huge, massive skills to get your head around, aren't they? And then going on to the next area, just like scientific attitudes. What is it that makes a scientist? You might be very good at planning, very good at recording, but if you haven't got the right attitude, you won't be a scientist. So going on to have a look at those. Scientists ask questions all the time, and then that's one of the things actually in the science programmes of study. It actually says quite a lot. Children raise their own questions, children ask questions. It doesn't say that much about children answering questions, and I think that's really worth thinking about. It's about asking questions. Scientists are passionate. They think about it all the time. I actually, and I work at York University, I often meet a scientist who does something with parasitic worms, and I often chat to her on the bus, and she's so enthusiastic because she really wants to know. It's going to make a huge difference in when she gets to, in Africa, the work she's doing. So she's passionate about it. Time. Scientists spend a lot of time. They spend years of their life. Think of Charles Darwin and those decades he spent getting to where he was. And precision. They work really carefully and thoughtfully, don't they? So moving on, just thinking about just one of those skills, one of those working scientifically skills. So in Key Stage 1, you've got all the skills. If we just move on slightly, sorry. There's a lot there to get your head around, isn't it? That's just by the time they're 7, being able to really observe closely, do simple tests, and then moving on as they get into lower Key Stage 2, beginning to think about measuring carefully. Well, if you've been teaching children maths, that's actually a pretty tall order, isn't it? And using a range of equipment, knowing when to use which bit of equipment, when to use a thermometer, when to use a jug, all these things. And then once you get into upper Key Stage 2, you're working with a great amount of independence. That's just one tiny strand of those scientific skills, isn't it? So, and then again, moving on. But that's just one tiny bit of what you're doing in school, isn't it? When you think about all the other things you do, and we'll just click once, and it's just, it's quite overwhelming, isn't it? That you've got all those other things that you need to do. And sometimes it can feel, I know science is a core subject, it gets squashed right out, doesn't it? So I think what we need are some quick wins. So moving on, I've got here, there's something in it. Me. Could I have me now? Sorry. Okay, yeah. I'm not used to this at all. I've got a real box here instead of a picture of a box. Right. So this is something you've probably done, and I think as we go through this, there'll be quite a few things you go, oh, I do that, or I used to do that, and I forgot about it, because we do that in teaching, don't we? We do something, and then we get so busy we forget we're doing something, and we don't always value what we're doing. And that's just this simple question, what's in the box? Can you ask me a question and think, what's in the box? What could it be? Now you could do it where you actually have a list of things up, and you can cross them off. Again, it's really helping children to think. So, what have I got in my box? Have you got any ideas? And you'd like to ask me a question about what's in my box? Alison, what do you think might be in my box? A question, answered yes or no.
Oh, is it heavy?
It's moderately heavy. Yep. So there. Does that help you a lot? Alan, would you like to ask me a question?
Does it make a noise?
Only if I shake it in the box. You knew you were.
Feel quite fragile?
No. And moving on, and these actually are fairly sensible questions. If I give you a clue and said something you could eat, again, that might make it a bit easier for you. So, Tanya, would you like to?
Does it grow on a tree?
Well, yes. No, most of it doesn't grow on a tree. Now, I like the way there Tanya asked a really sensible question. If I was asking a child, they'd probably say, what colour is it? And yes or no, you can't answer it. And so you're building up those questions with the children all the time, aren't you? Giving them clues. They've really got to develop their analytical thinking. So actually, inside my box, we have got, I'm not going to carry on because I think it'll just take too long, some tomato ketchup. And later on, we are actually going to be doing some of the science of tomato ketchup. So that's something for you to be looking forward to. So moving on to the next slide. Thank you. So by doing something like that, you've got the chance to assess what children know, develop the skills of precise language, asking questions that people will understand what you mean by the question, so it's, you know, like if you said, what did I have for breakfast, that wouldn't be a very good one. Careful use of vocabulary, and you can also let children take command. They can start putting things in the box. So moving swiftly on to the next slide, which is hopefully going to appear. Right, the next slide is actually a picture of autumn leaves. I spent yesterday going out collecting autumn leaves, and there they are, sorted by colour. And that is often what will happen in nursery. Your children will be sorting by colour. Reception, really time to start moving them on. So if we go on to the next slide, it's like, again, those questions that can be answered yes or no, yellow or not yellow. And there's got so much potential. What do we mean by yellow? Is it just if it's got a bit of yellow on, or has it got to be all yellow? What shade do we mean by yellow? Another question children ask, is it big? What do we mean by big? You could be really precise, haven't we? How can you describe those different features? And actually, I still link this a lot with something like poetry, where children have got to really look, to really ask those questions, not to just ask the same questions over and over again. So, and if we move on to the next page, it can get more challenging, can't it? This is just, I just went around my garden, and these are all leaves that are finely divided. Now, what sort of questions would you ask here? Now, you wouldn't probably do this for most children. This might be too challenging. If you've got somebody who's interested, and I think it's about finding things children are interested in, isn't it? If you've got a child that's really interested in angling, can you imagine giving them lots of fish to sort? Or that child that likes horses. I've got a little picture of apples there because we had an apple day at our school where all the children brought in apples that had grown on their trees. We really had to really look. They were all apples. They all look so different. It's about using those, using the children's interests. I've got a picture of Charles Darwin there because you could have different scientists. You know, we're supposed to know a lot more about scientists now, aren't we? Pencil there because I think we don't draw enough in primary science. If drawing, you have to really look, really notice the form of things. And the magnifying glass, we have to give children a magnifying glass. A, we forget to show them how to use it, and B, we give them things that aren't worth looking at. You'd really need a magnifying glass to look at those, wouldn't you, and start sorting them out. But, we go on to the, now we're going to go back to me.
Yep.
So thinking about where things are all the same, how would you sort these liquids? So we've got some cooking oil, tomato ketchup, soy milk, some honey, incidentally for my own bees, in case you're interested, and this is water. And I've just coloured this water so you can see it, but what sort of, how would you sort those? So, lots of different ways that you could. And is it possible to go to the next slide? Sorry. And now we're beginning to have opportunities to cover quite a lot of the programme of study. Sorting everyday materials, you know, describing the physical properties of a material, comparing and grouping materials, working scientifically. So it's not just what you can see, but what tests can you do on the materials. So to start off with, we're going to do a very simple test on viscosity. So if we go on to the next slide, I'll just show you two different ways that you can measure viscosity. And hopefully there's a little, if you press that, you'll see the ball should move there. Now that's one way that scientists measure viscosity. They'll drop a marble into or a ball bearing into some fluid, and they measure how long it takes to drop. So we go back onto the. So here we've got two liquids of very different viscosities. This is just washing up liquid. It's a nice thick washing up liquid, and this is water. So just see. If we just drop the balls in, they've both got same volume, and you can see straight away there's a completely difference between how long it takes for the marble to drop. You can time that, and you can measure how viscous things are. I chose this washing up liquid because it's very viscous, but when you've got things like oil or milk that aren't that much more viscous than water, it's a lot harder to measure. That would be quite a problem for children, and I think that's the sort of challenge that I'd like working out. How could we measure that? What would we do? So today we're actually going to measure viscosity using the simple, just a normal tray, and on the back you can do it without the bits of tape. I'll just put some bits of tape on so that they don't all run together. And I'm going to put about 5 mils of each of the liquids on here, and then we'll see which is the most viscous. So I'm going to have like the ketchup. And what you want is a nice little blob of, ooh, there's the ketchup come out. So that's probably a bit more than 5 mils. We'll just see that there. Then honey is the next one. Just while I'm doing this, and this is what you'd be doing with your children, isn't it? Just be thinking, which one do you think will be the most viscous? Which one do you think will get to the bottom first? So there's the honey. It's quite runny honey. We actually won a prize with this honey the other day, so at the honey show. So next we want the oil. So again, just a little tiny bit of oil. This soon gets very messy. A bit of the soya milk. I've got some teaspoons here because I was going to measure it out carefully. But there we go, a little blob of soya milk. And last of all, this is the water. I've just put a bit of food colouring in so that you can see what's happening. And as I say, these little bits of tape just stop it. And there, that just stays in a nice little blob held by the surface tension. Are you ready for this? I'm just going to gently lift this. We're going to see how quickly they get to the bottom. Let's just have a little cloth at the bottom, shall we? There we go. So, are you ready? Which one do you think is going to be there first? Which do you think is going to be the slowest? Which is the most viscous? Let's have a look. And there we go. So the water and the soy milk got down very quickly. There goes the oil. Then the honey. And now here comes the tomato ketchup. You see the tomato ketchup is a lot more viscous than the others. That's why it's hard to get out the bottle. So if I put that up vertically, you can still see. So there's a big difference in the speed that it takes the water and the honey and the tomato ketchup. I think I'm going to stop that there. I think we've got the idea. I've spoken to people who've been a bit apprehensive about doing that in the class. I think it'll get very messy. I've done this with year sixes, reception, nurseries. It's not actually as messy as you think it's going to be. So, and it's quite good fun. Right. So, moving swiftly on. Ah, yes, we can go on to the next slide. I'm keeping Alan very busy here, slipping between. Oh, the tray. I'm just going to give the tray to my assistant because we might be using that again later. Thanks, Tanya. Brilliant. And I have actually found some figures here. I couldn't find the viscosity of all of these liquids, but I do know that olive oil is about 100 times more viscous than water, and honey about 1,000 times more viscous than water. So, and then if we move on, just slight aside here, while I was researching the viscosity of different liquids, this is an experiment. This is actually a screen grab, but it might as well not be. It's a screen grab from the longest running experiment in the world. It's been going for over 80 years, and that's actually pitch in there. Now, pitch is that black, to all intents and purposes, solid substance that the road's made out of. but it is actually a very, very viscous liquid. In over 80 years, only 9 drops have fallen, and pitch is actually 230 billion times more viscous than water. So a little bit of unwanted information there, but quite interesting. Moving on. So we've measured the viscosity of these different liquids. That's a nice word, isn't it, viscosity? But now we're going to measure their stickiness. So just thinking about stickiness, how do we measure stickiness? So I think we can go back to me now. So one way is just to put your fingers in and have a little. So that's the water. That's not very sticky at all. Do I want to put my fingers in the honey? Just a little bit of honey, and you can see that's the one that feels the stickiest of all of them. But what we're going to do now is have a little play, because it is all playing, isn't it, really? Even real scientists, I think. So we've got a little experiment I've got set up here. This is just a little bit of paper, folded over at the top, held in place on my washing line with some pegs. Now then, I'd like you to have a little think. How many pegs? So if I was to take this 10 centimetre square of paper, if I was to put a thin layer of tomato ketchup just there, that is 1 centimetre wide. If I was to a little bit of tomato ketchup and then stick it there like it's a post-it note, how many pegs do you think that would hold? How many pegs do you think that would hold? So let's have a go. I hope you're thinking about this. Got a little prediction in your head how many it might be. So I'm just going to use my finger to spread the thinnest of layers. Nice tomatoey smell here. I know some of you will be thinking, I don't want to do that in my classroom. Honestly, it really isn't that bad. It really isn't. So, and then the important thing is just make sure it's that 1 centimetre. Really, really firm the contact. You're going to want to do this with all of them. So, how good an adhesive do you think tomato ketchup is? How many pegs do you think it will hold? Just a note here about why I'm using pegs. Why aren't I using weights? Well, the problem is fixing weights to the paper. You can, often the paper gets torn. So pegs work quite well. So do you think it will hold it? Do you think it will actually hold a peg? Let's have a, and if people in the room could be counting so I can keep talking without counting, that'd be really good. So,
2.
Are we still on?
Yes.
Yeah, I'm just the other thing. Let's just put another peg on. So we've got to the 3rd peg. Are you surprised? This is still looking quite strong here. Now, an interesting thing is these particular pegs weigh about 5 grams each, which is really handy when it comes to working it out. Obviously, you can weigh at the end. So 7. I'm running out of my nice pegs, so I'm just using any old sort of pegs. I'm putting on 2 at a time now because by now you'll see actually tomato ketchup actually holds quite a few pegs, doesn't it? In fact, I think the tomato ketchup is 11. That's actually the lowest number I've ever had for tomato ketchup. Having said that, I think that's better than the Post-its we used to have in school, which used to fall off all the time. So, are you surprised by that, or? So, that's not much information on its own, is it? Now have a think. If we think about the honey, do you think the honey's going to hold more pegs or less pegs? Should we try it and see? So I'm going to get a new bit of paper because this bit of paper is now contaminated with tomato ketchup. What time am I supposed to be finishing, folks? Because this actually we started a bit late, didn't we?
5.
Right, yeah. So I'm just going to put a tiny bit, just the same again, just a really thin layer. Just probably got a bit too much there. This has got a bit sticky. Right, more pegs or less pegs? So we had the tomato ketchup was 11. I spent my day at home yesterday in the kitchen sticking things with tomato ketchup and jam and mayonnaise and honey. Just the importance of repeat measurements, which obviously we're not going to do now. So if I'm just going to do one at a time. So we're on honey now. So there we go. Got one. So it's holding up well so far, and it is very, very sticky. So one would imagine that it might make a good glue. Oh, got 3. And that is typical, actually, the honey. To everyone's surprise, mine certainly is not a very good glue. So, but what a lovely thing to do with children. Lots of chance to do repeat measurements. Take that into your maths lessons. In fact, I would do this in a maths lesson. You could be counting how many pegs you're using for younger children. If you started counting in 5s, how many grams you're using, if you give them pegs that are about 5 grams each. Perhaps thinking about timing it. Or if we just go on to the next slide, there's just a picture of tomato ketchup. Think very carefully about this amount here, because one of the things I did yesterday, I used a 3 centimetre, I had 3 by 10, and that used 90 pegs for the tomato ketchup, and after 24 hours it was still, I'd used up all my pegs, it was over half a kilogram. So you do just want a tiny, tiny little bit of stickiness. So again, that's just one of the problems, and it's quite nice to think about that sort of thing as you're planning with children. You know, you might start off using a bigger amount. Everything sticks really well when you've got a big amount. You need that small amount so that you get that differential. So, moving on. So we're just going to have a quick look. Was there a correlation? Oh, yes. So in what order would you predict these liquids would support the pegs? So moving on, in my kitchen yesterday, in fact, the tomato ketchup held 37. The worst was olive oil, which actually didn't hold any pegs because 1 is the number that it was holding when it fell off. So as soon as I put a peg on, it just came off. Water at 5. Honey actually did a lot better in my kitchen, and perhaps it's because it's quite warm in here. We're obviously getting lower numbers. But anyway, but in class, numbers, finding averages, lots of activities for a maths lesson. So, just one more thing, if we can just go to me again. This is something that you could be thinking about. We're not going to actually do it now, but here I've got, this is water into which I have, thank you very much, into which I've dissolved sugar. So 100 sugar in 100 mils. And you'll see this one has actually got 200 grams. I think it's probably saturated. I couldn't quite get it all to stir in, so it's quite a lot of thickness. This would go really well with, I think, some of the year 6 where you're thinking about dissolving. That's 150 grams. When I was stirring these, I noticed they made very different sounds. And I don't know if it was just because of the volume or whether it was because of the sugar in the water. I think that'd be a really nice thing to investigate. But anyway, we've now actually, it's all the same stuff, whereas before we've got lots of different things. Now we've got different stuff, but with different viscosities. So just having a little think, how do you think they would do, on that running down the tray? Which one do you think would be slowest? Which one do you think would be fastest? Do you think it would make a difference? Which one do you think would be best? Would it be the plain water or the one that's got lots of sugar in? Which would be the best at sticking? So these are all things that you could investigate with children. Just really nice to start thinking about these things, isn't it? So just going on, I think we're quite near the end. I think get onto the slides again. Need to whiz on. Yeah, so moving on from there. So, oh yeah, was there a correlation? And there wasn't between the viscosity. But we're thinking if you used the sugar and water, where you've ironed out those other differences, would they be the same? And moving on, these are some of the questions that you might be wanting to ask with children. As I say, we're not going to do it now, we'll just be thinking about that. And then just going on to the last slide, just going back to all those issues. So what have we done in this session? So next slide is, we've done a bit of classifying and grouping, we've done some pattern seeking, and we've done some fair and comparative testing. We've had chances to plan, observe and record. We have asked lots of questions, and I think there's lots of questions that you could ask as you go through. Now, it's a bit questionable, would there be time? Would the children be passionate about it, and would they get the chance to practice the precision? So just moving on and moving on again. And just thinking about, again, that crowded curriculum and moving on. But hopefully you can see that because the subjects, they are all crowded on top of each other, but there's lots of ways that they can be mixed. So moving on, sorry. So I think a lot of this you could actually do in a maths lesson. There's lots of opportunities to weigh, measure, time, graphing, ratios, whatever year group you're teaching, there are opportunities. And in English, moving on, opportunities to describe, to explain, ideas for poetry. We talked about ideas for art, all sorts of things. So because if you combine it with other languages, there you've got your chance to build up children's real interest and give them the time to develop the skills that they want. So I think that's more or less come to the end of what I was doing. So any questions?
We've got one about how you would expect your Key Stage 1 children to recording. That was when you were looking at the investigations around running liquids.
When we were running them down. Yeah. Well, there's quite a lot of things you could do, isn't there? I mean, photographic evidence would be quite nice. It's annotated. I used to, with reception in year 1, I used to take a lot of photographs and get children to make notes afterwards. Just see where I just had the bits of paper, just write the numbers on. She could actually run some paper down there and then perhaps order them in, which would go quite well with learning ordinal numbers with the youngest children. They know which was first, second, third. So you haven't actually got to be thinking about the actual time, you know, it took 0.3 seconds or whatever, which is really tricky, isn't it? But you could say it was the fastest or the slowest. So anything you want to add to that, Tanya?
Thank you. No, I think that's great. Yes, I think that's lovely. Do you know what you're going to be covering next week?
Well, I was one of the things I was going to say was if anyone wants to tweet me things they'd like covered, because one of the really difficult things about doing this is I don't know who's out there, and usually if you're working with a group of people or when you're working with children, you know what people need and what people want. So any ideas, I'm really happy to adapt what I'm doing. Yeah. But we were going to be thinking about ways of asking questions, you know, and getting children to ask sensible questions.
At Science Voice.
At Science Voice, yes. Thank you very much.
Okay.
Thank you very much. Oh, and next week, I've remembered, I was going to have a cliffhanger. Next week, I'm going to tell you how a baked potato in a class of year 5s nearly ended my teaching career. There, you want to come back now, don't you? There you go.